Welcome back, class. In this video, we're going to take a look at some type 2 compounds, and we've already stated that type 2 ionic compounds, okay, this means that we'll be working with transition metals. All right, transition metals. So here's a classic example that is used to sort of help understand this. Let's take copper. So if we go to the periodic table, and if we zoom in, we'll see that copper has two oxidation states. It has a +1 and a +2 oxidation state, okay? And we'll mix it with sulfur. So we can see that sulfur, it has this -2 oxidation state, and this anion, for the purposes of what we're looking at, is always going to have that oxidation state. You'll see here, you'll notice in the box, you'll see the -2 and it's italicized. It's because that's its main oxidation state. So let me go ahead and get rid of all that. And let's go back here and let's take a look at what we got. So we have copper. It has a +1 oxidation state, and we have copper that has a +2 oxidation state. We're going to combine this with sulfur that we know has a -2 oxidation state. And so we ask ourselves, what would need to happen so that the sum of these oxidation would equal 0? Well, we want this to equal a -2, and we want this here to equal a +2. So obviously we would need 2 of the cation and only 1 of this anion here. The 1 is understood, so we don't need to write it. We're going to draw our arrow, and so we need 2 of these copper ions and 1 of this sulfur ion here. All right. So if we follow the way that we've already been naming this with type 1 compounds, we would call this copper sulfide, all right? Now, just hold that thought. We look at this and we notice that we've got +2 and -2. The sum of both of those numbers is already 0. So all we have to do is bring that together and we get CuS. And in the spirit of how we were naming type 1 compounds, we would say copper sulfide. That makes sense. So at this point, to name type 2 ionic compounds, and type 2 means that there's a transition metal, what we do is we look at the charge on the cation. And we want it, because the only thing that is different between both of these compounds is the cation. The anions are exactly the same. They have the same charge, the same atom, everything. So the charge on the first example is a +1. So what we're going to do is we're going to come over here and we're going to put a Roman numeral 1. And so at the top, what we wrote was an ionic equation, a balanced ionic equation for copper 1 sulfide. And then on the bottom example, we see that there's a +2 charge. So we're going to put a Roman numeral 2. And so CuS, we would name that copper 2 sulfide. And so you can see here that one of the confusions that usually happens is that students will use the number that's here in here for the Roman numeral, but that is incorrect. Remember, the Roman numeral has to match whatever the charge on the cation is. Okay. So let's look at another example. Let's kind of go in reverse. All right, let's go with, how about if I give you a name? Let's go with iron 3 sulfide. Okay, iron 3 sulfide. So let's write the balanced ionic equation for iron 3 sulfide. Well, iron, that's the Fe. The number, the Roman numeral, lets us know that we're dealing with an iron that has a positive 3 charge. So whenever we see, remember, the name that has a Roman numeral lets us know we have a transition metal. And if we go to the periodic table, we can see right there, there is iron. It's in the transition metal section. And if I zoom in, you can see that it has a positive 2 and a positive 3 oxidation state. In this example, we're just simply looking at the positive 3. All right. So now we're combining that. It says sulfide, so that must have been sulfur. And we know from the periodic table and past experiences that that's a negative 2. So now we ask ourselves, what's common between 3 and 2? And that's 6. So what we need is we need to come up with something here that's a positive 6 and add it to a negative 6, so that equals 0. Okay? So we know 2 times 3 would be 6, and that would be positive. And 3 times 2 would be 6. That one would be negative. So for our type 2 ionic compound, iron 3 sulfide, we would need 2 iron 3s, 2 iron ions, and then we would need 3 sulfide ions. And so iron 3 sulfide. Okay? Now, in the spirit of what we have been doing, let's go back and let's take a look at something like our, let me go ahead and erase this. Let's take a look at how we would do something with, say, our ionic bonding like we did with type 1 compounds. Let me bring this down a little bit, give us a little more room. All right. So we have 2 coppers, and both of those coppers have a 1 valence electron. We know this because it says copper 1, so there must be 1 electron that's going to add. And we're going to add this to 1 sulfur. And sulfur, we already know, being in the group that it is, it has 6 valence electrons. So now I'm going to go back, I'm going to make this yellow to stay standard so that we can kind of see the difference, what's going on. We know that this electron will be added by copper and taken away by sulfur. And the same holds true with this electron here. Because remember, ionic bonding is about the transfer of electrons from the cation to the anion. So now that that's there, we have this copper, and we have 2 of them, and each transferred, added 1 electron elsewhere. We now have this sulfur that already had those 6, but it took away 2 electrons. It took away 2 electrons. So now what we just finished writing was the process where we're showing ionic bonding that forms copper 1 sulfide. All right. So let's look at something maybe a little more complicated. Let's go back to our example here with our iron 3 sulfide. So according to this, we need 2 irons. So there's 1, there's 2. This is iron 3. So I'm going to put 3 valence electrons around each of the irons. We had to have 3 sulfurs, so there's 1, there's 2, and there's 3. And each of these sulfurs already has 6 valence electrons. So let's go ahead and get those 6 valence electrons around our atom. Okay, and let me be consistent, and I will come back here put these in yellow. I just think sometimes color coordinating things, like, and you should do the same on your notes. You color coordinate what's going on. It really goes a long way with helping you understand what's going on. Okay? All right. So this sulfur right here and this one each are going to take away 2 electrons. This iron here is going to add those 3 somewhere, and this one's going to add those 3 somewhere. Okay. So we can see that an electron would transfer from here to this empty space and from here to this empty space. And then this one right here could go to that empty space, and this one right here could go to that empty space. This one can transfer from here to here and here to here, like so. And then you'll notice that not one time did I crisscross the arrows. You want to make sure that the arrows do not crisscross. You want there to be no confusion as to where your electron is transferring to. Okay. So now we draw our yield arrow. We see that we have 2 irons, and each of those irons, now that they've added the electrons elsewhere, are carrying a positive 3 charge. We see that we have 3 sulfurs, and the sulfur already had 6 valence electrons, and each of them took away 2 electrons. So now everything we have here represents our ionic bonding, showing the transfer of electrons from iron to sulfur, so for our iron 3 sulfide. Hope these examples helped. Work on those practice problems. Reach out to me if you need some help. I'm always here for you. Stay curious, and I will see you in another episode real soon. Bye.